Recall earlier, like back in Calc 1, that we saw the derivative of transcendental function ln x, and as a reminder, transcendental functions are simply non-algebraic functions, is an algebraic function. So the derivative of ln x was 1 over x, which is in fact algebraic. Likewise, what we see is that the derivatives of inverse trigonometric functions are also algebraic. So let's start off with a theorem here. Let's say u be a differentiable function of x. In other words, u equals some function g of x. Now, in the simplistic case where u simply equals x, the most simple function of x, well, I'll modify this in just a moment. So, if u is some function of x, then the derivative of arcsine of u equals u prime over the square root of 1 minus u squared. Now, obviously, this u prime right here, this comes from the chain rule. This is a result of the chain rule. But notice, if we have this scenario where u simply equals x, well, what's the derivative of x? It's just 1. So if this was a scenario where it was arcsine of x, ddx of arcsine of x would be, this is going to be an x, and this is going to be x prime. But what's x prime? It's just 1. So I can eliminate that and simply write 1. So the derivative with respect to x of arcsine of x is 1 over the square root of 1 minus x squared. With this scenario where I have u, again a function of x, that's when I need to be concerned about the u primes up here. And that applies to every single one of these. So let me erase that and just remind you again that u equals some function of x. Now, arc cosine of u is a negative u prime over square root of 1 minus u squared. Notice that this is really nothing more than the negative of arcsine. They're identical with exception only to the sign. This is a negative. Now, arctangent of u equals u prime over 1 plus u squared. Again, as a reminder, if u equals x, this would be a 1, and this would be x squared. And as you probably guessed, the derivative of arc cotangent is the negative of arctan. Let me write this like this. Let's add this. This equals the negative of, I'm going to use the shorthand notation, the negative of arcsine. This equals the negative of, well, actually that's not true. It's the negative of d dx of arcsine. And here is the negative of d dx of arctan of u. Now, arcsecant, d dx of arcsecant of u is u prime over absolute value of u times u squared minus 1. And of course, as you probably suspected, arc cosecant, the derivative of arc cosecant, is going to be equal to, there's my negative up there. So I could write this as this is being equal to the negative of d dx of arcsecant of x. These differ only in sign. Now, because of that, what I highly recommend to you, and really what we typically use by convention only, I highly recommend to you that you just remember that these are the negatives of the counterparts, and there's really only 3 that you need to memorize, because derivative of arc cotangent is the negative. Just slip a negative in there, and I'm there. Now, let's just very quickly prove one of these. I'm not going to go through all of them, but very quickly we can take a look at the proof of one of these. I want to prove the derivative for our arc cosine of x. So y is equal to arc cosine of x. That means that d dx of cosine of y equals d dx of x. Now, why is that? Well, if I simply take cosine on both sides, cosine of y equals cosine of arcsine of x, that's just x, right? So then I just took the derivative, whoops, of both sides. That's the one step that I skipped in there, hoping that you would see it. But just in case, there it is. So if I take the derivative of cosine of y with respect to x, I need to use a little implicit differentiation. I'm going to end up with a negative sine of y dy dx. Implicit differentiation, because y is the implicit function of x. This is equal to 1, because the derivative of x is just 1. That implies that dy dx is equal to a negative 1 over sine of y. But this is equal to a negative 1 over sine y is the square root of 1 minus cosine squared of y. Because as you may recall, 1 minus cosine squared is sine squared, so square root of 1 minus cosine squared is going to be sine. Now, we also said here, where is it? That cosine of y is equal to x. That came directly from this statement. So if cosine of y is equal to x, and then this is actually equal to negative 1 over the square root of 1 minus x squared, which is exactly what we said it would be. Remember here, u is a function of x, but in the case where u is x, this is just a 1, and that's an x.